Okay, is that all good?
Yeah, perfect.
Is everybody in? Yeah. Right, okay, good morning, everyone. My name is Matt Siddon. I work for IMO Precision Controls. I'm one of the regional managers for the Southwestern Wales. Thank you for joining today. We really appreciate your efforts to be here. We're going to run through a couple of things this morning surrounding true DC isolators versus modified AC. So some of you will be thinking, well, what's the difference? And that's exactly what we're going to talk about today. And there is a big difference. And we've put this training on because the feedback we had from the solar show at the NEC going back about 6 weeks ago was that people are finding that DC isolators are burning out all the time. The problem that they've then got is they have to go and replace them for free or under warranty, which is time that's not used in the right way. So we're going to explain why that is happening, first of all. So we'll explain why it's happening, and then we'll explain the differences, the changes that you can make to stop it happening in the future. My contact details are here. So if you haven't already, please do connect with me on LinkedIn. And what we've actually arranged today, thanks to Jasmine and our marketing team, is everybody that has attended today will get a free IMO goodie bag. It's got sort of woolly hats and for the winter and coffee cups and things like that. So if you pop your company address on an email to me, then we'll arrange to have one of those sent out to you. Okay, so the agenda for today, the quick introduction from me. Isaac, who is my colleague, sat next to me. He is the product manager for the IMO True DC isolator. So he will go through the differences between the IMO offering and what many of you are currently using in the market. We've also got a couple of guest speakers in Luke Gonzalez, who's a renewable fire safety expert. Luke will be discussing the fault reports and what the findings were from faulty DC isolators. And we have Steve Humphreys from NAPIT, who's going to talk to you about regulations today and how you can make your solar installs compliant. So, and at the end, we'll have 15 minutes just to answer some questions, and you can put anything to us that we've not discussed in the presentation. Okay, so I'll pass you over to Isaac now, and he'll talk you through the product.
Good stuff. Thank you, Matt. So as Matt mentioned, I'm Isaac Osei. I am the product manager for IMO solar offering. We do a huge amount in terms of renewables protection, so EV and solar. On the solar side, we coined the term true DC quite early on within the industry. And that was really to distinguish the difference between what we offer and what we find on the market that other installers were using. We've established ourselves as somewhat of a market leader in terms of DC disconnects globally. So the product, as you can see, has various approvals from UL to Australian approvals also. And with that, we've seen over 8 million installations worldwide. One of the main factors for us, obviously, with any sort of solar installation is safety and reliability. Obviously, we understand for installers, going back to site in a lot of cases can eradicate margin entirely. So one of the things that for IMO as a business that we really wanted to stand behind is that reliability aspect, and that is backed with a 5-year warranty, which isn't the case in terms of other isolators that you find on the market, which are limited typically to a year. We've mentioned the true DC isolator, not modified AC. We're going to go into a bit more detail in terms of what that is, and we'll accompany that with a demonstration within this presentation this morning. With that, we've got a rotary knife contact mechanism inside the isolator itself, and this is how it provides a double make and double break action per contact. So you can see there we've got a bit of a diagram showing this rotary knife contact, where effectively the contacts have this action as opposed to your typical opening and closing of an AC isolator. The arc suppression time, which particularly in the case of DC, where you've got quite large arcs that can occur. The contact suppression time for that, you're looking at typically 3 milliseconds, which for us is important that is maintained. Any inconsistency in that can present a risk. So with our DC isolators, you do have your arc chamber built in, and within our range, it is rated for up to 85 amps at 1,000 volts. As we say, typically for residential, but also commercial installations. Also, the plastics used in the isolators themselves are UL 94V-0, which means that they are flame retardant, so they actually are self-extinguishing in the case of fires, and they provide the lockable option as well, so they can be locked off. Being a true DC switch, it is a compact and optimized solution for DC, which, where compared with a modified AC switch, in order to modify an AC solution and make it work retroactively for a DC application, you tend to find much larger components are needed to be able to accommodate or cater for the direct current. So in the case of a true DC IMO switch, it doesn't need to be oversized. It is made for purpose.
Okay. So this is a quick video because we've got some people that are new to the industry. So we just wanted to explain a little bit in more detail about what ARC actually is. And this video here basically simulates effectively a faulty MC4 connection. It also simulates what's happening on the inside of a modified AC isolator. So as the contact opens and closes, because it does it at such a slow rate, this is what can happen inside those, which leads to your burnouts, etc. So here's the difference between the action of a modified AC and a true DC. So the first video is what we're seeing a lot of the fires within. So what they have is some loops in the top, which are DC cable, and they're used to share the load and share the heat. And this is how the contact operates. So if you imagine you pinch your index finger to your thumb, you've got this kind of like opening and closing, and we can control that on the switch itself. So it's either neither open or closed, and you can hold it in that position. So if you imagine the video with the cables, that's what's happening inside this switch when the DC passes through it.
So on the right hand side, you can see a true DC IMO switch, where if you see on the reverse, you will see, and try not to blink, gents, when you see this demonstration. As I say, it's suppressed within 3 milliseconds. The key factor here is it's operator independent. So you will see that regardless of how quickly the handles actually operated in the video, the snap action takes place independently of that speed. So regardless of how it's operated, you can be assured that you're going to have a suppression within 3 milliseconds. And that's because the DC switch mechanism has a spring loaded mechanism to give you that sort of arc suppression.
Yeah, so what you'll also notice if you've used one of our DC isolators before is you will turn the handle sort of 7/8 of the way and nothing happens. So with the modified, you can open and close that that contact, but with ours, you turn it 7/8 of the way and nothing happens. But the final eighth is the snap on to off or off to on within 0.3 of a millisecond to negate any arc. So we want to talk to you about a couple of products that are kind of the hot sellers in solar at the moment. So if you can see the screen here, you've got your typical domestic on the left, which is you've got 1 or 2 strings on a 3-bed semi, and you're sticking some panels on the south facing side of the roof. So you would typically use this enclosed body isolator and you can put 2 strings into one of those isolators as well. So we make a single pole version and a 2-pole version. The one that we're going to talk about as well in a little bit more detail is for those doing a commercial install, which is where we have the DBL. So what, if you can have a look at my screen at the moment, what we have here, the idea of this is we take the isolator out of the box on the left, and we put a little handle onto it. So if I can open this one, so what you can see here is our string box. Can you see that properly?
Yes.
Yeah, perfect. So in here, we're actually isolating 10 strings in a box that is no bigger than, well, the width of me, actually. The whole point is that we're seeing a lot of people install solar on factory roofs and things like that, where you've got an excess string, sort of like 20 to 30 strings on the roof. And if you were going to use the solution on the left, that's a lot of holes that you're going to have to drill into the wall, so 4 per string. So what you end up with is just a long line of little enclosed DC isolators. So we've got this solution so that effectively you can isolate all of your strings in one box. So but you would put this box on the wall, so it's 4 holes drilled, and then you would wire up through this box. The biggest box that we have is about the same width as this, and it's about double the height as well. And you can actually isolate up to 24 strings within that box. So it's a compact design that's perfect for commercial installs.
So the added benefit in terms of these sort of installations, what we find is for installers, a lot of the time it can be the case that they feel quite limited to just having an enclosed isolator per string. But this is where they can be quite smart in terms of consolidating. So aside from offering the string box solution where you've got several different isolators all inside one enclosure, we also offer multiple pole isolators. So you can have up to 8 poles. So it will be a string per 2 poles. So you can have, for an 8-pole isolator, you can have up to 4 strings. Now that just helps for some installations. It helps the installer to be able to consolidate the number of isolators needed if they don't need independent switching of each string. So we offer various sort of solutions to help in terms of making an installation neater or just a bit smarter. So you can see there, we've got an example of a 4-pole isolator being used in a 2-string system, where you've got each string connected to 2 of the poles on the isolator, and that just provides a neater installation as opposed to having 2 isolators, 2 separate isolators upstream of the inverter.
What you'll also notice here about the wiring is that it's very different to the modified AC versions of a DC. So typically what you would have is your 4 cables coming in, and then they would come directly out the bottom of your 4 holes in the isolator. But with our design, because of the way that the switching is done, you actually have to, they will be, how do I explain this? So the string 1, as you can see on the left, you've got your pos coming in, and then it goes out the opposite side. So if you have a look at the isolator itself, what you'll notice is they're stepped. So you can see the steps going down on a certain for the certain inputs and outputs. So all you do is match the depth of the so the first one would come out of here, for example, and then it would come out of the other corner. If that makes sense.
Yeah, no, so that's because of the knife action contacts that we mentioned earlier, where as opposed to having contacts in parallel in an AC, because of this knife action, you basically have a circular mechanism. So in order for that circular mechanism to operate as it should, you need to have the contacts adjacent to one another as opposed to opposite.
Okay, so here's an example of the multi-string just coming in again. So it's that same 2-pole isolator, and then you can just build a box to suit. So the boxes start from 4-way, so you can stick one of these modules into a 4-way box if you wanted to, which would be perfect for a domestic install as well. The biggest box that we make here is a 48-way, so you can put quite a few of these isolators in. So for example, the box that I've just showed you, the 18-way, that would be perfect for an installation like this, because you've got 8 strings and you can put 4 of this this isolator on the right hand side into that box and isolate 8 strings out of a box that's no wider than I am. So this will be the perfect box for that specific install.
in terms of ratings, and this is somewhat has become a dark art in terms of the selection for DC isolators or the correct specification. We get calls on a daily basis from installers just to help them in terms of selecting the right isolator for their application. Now, the biggest reason for that is, unlike an AC switch where it's quite clear, you need a 40 amp, let's say, for a certain voltage application. When it comes to your DC, the ratings do vary depending on the voltage that we're working at. So depending on the PV panels that are being installed, the suitable isolator may vary. So you can see there it's an extract from our data sheet. You can see where we actually provide a detailed breakdown for installers to be able to understand exactly what performance that they can expect from each isolator model. So whether it's our SI16 there at the top or our SI65, instead of just saying like you would an AC isolator that that's a 65 amp, actually you can see there in the case of the SI65 there at the bottom, for 500 volts, it would actually give you up to 76 amps. Whereas where you get to 1,000 volts for the same switch, you'd be looking at 40 amps. Now, that's obviously something very important to consider for any PV installation. It's not as binary as saying, I've got a 55 amp DC isolator, I can use it for 1,000 volt installation. So it's just to illustrate that for us, especially as a manufacturer of isolators, we need to provide our installers with all the required information to be able to make the right decision in terms of the kit they use for each application.
Yeah, and also it's probably important to say as well, we get quite a lot of quote requests through for a 40 amp DC switch, and when we ask the questions about why they need a 40 amp DC switch, and it's normally because they're replacing a faulty one on somebody's house. Now, because of the ratings on our switch, a 40 amp DC isolator from IMO is way too big for most, I would say, if not all, domestic installations. So when we actually find out what panels are on the roof and what power ratings they are and how many are in each string, typically the one that would go out to that customer then is a 16 amp switch. So some people might think that, oh, the IMO switch is quite expensive, but it's actually not, because a 40 amp switch is the equivalent to our 16 amp switch, which is our baseline model. So if you're comparing apples for apples there, you'll find that 40 amp switch with the modified AC, not only has it got less capability, but it's probably going to cost you double, if not triple the price from the wholesaler. So when it all goes wrong, so we put this slide in just to give you a couple of bits to think about when things go wrong with a modified switch. So typically, if you've got to replace one of these under warranty, you've got to replace your isolator. So we've estimated that is around £30. The labor cost to then go and do that is sort of £200 to £400 a day, depending on if you're an electrician, if you're an engineer, whatever it might be. But then you also have to think about the loss of power for the house owner as well, because if that isolator has gone pop and they're waiting for you to come and replace it, they're not generating any power as well. So that's important. That could cost roughly about £10 to £20 a day. But if that's a commercial or industrial system, that could be hundreds of pounds a day. So there's not only a loss to you because you're having to go and replace it under warranty and buy it yourself. The consumer is also losing money because they're not generating their own power. You then also have to think about things like, if that isolator is going to go pop, then what else is it going to take out? I spoke to a couple of guys at the solar show that said that we had an isolator that burnt out, and it took out most of the cable run. So it took out about a foot of the cable run. So they then had to replace all of the cable going up to the array on the roof. And again, I don't really know how much cable costs, but I can't imagine it's cheap. And You then have to think about your labor to replace said cable run. But I think most importantly, the impact that it's going to have on your credibility is probably paramount, because a lot of work that's generated through the solar industry is from word of mouth. So my neighbor John had a solar install, and he recommended his installer to come and do mine. But he's not going to recommend it if it constantly trips out, if things are a fire risk in that install. You're going to lose potential business by not putting in the right things. So just a couple of things to think about there, for the sake of saving a couple of quid, because the difference, honestly, guys, the difference is probably a tenner in the modified AC favor. But then we've talked about you would need a 40 amp isolator to do the same job as the 16. So this is the 16 amp version of the IMO isolator. So this training is to inform that maybe you might see our 40 amp equivalent is a lot more expensive, but you probably don't need it.
Yeah, it's just before Matt moves on. It's what we really want to highlight is it is somewhat of a false economy, that where some installers think they're saving on a few quid. Actually, in the long run, when you consider the big picture and when you consider the potential implication and impact, it ends up costing significantly more than the difference in cost of getting the correct product for the job, as opposed to getting a cheaper alternative.
Yeah, we also looked at the average cost for a domestic install on a 3-bed semi-detached home, and it's roughly £9,500, I think, all in. So for the sake of saving a tenner on the job, I mean, it's absolutely nothing compared to the overall cost of the kit. Right, okay, so that was the introduction to the modified AC versus DC. We're now going to pass over to Luke Gonzalez, who is a solar safety and renewables safety expert.
Lovely, brilliant, thank you, Matt. Right, just a quick one to say thank you for attending, and IMO obviously for hosting this event. I'm Luke from CGM Group. I specialise in renewable fire safety, and it's a pleasure to be here. And hopefully everyone here can take something away from this today, and we can learn from these mistakes and issues and make the industry safer and better. So if I can just get on to the next slide, please, Matt. Okay, just a quick agenda. We've got a bit of introduction, some UK statistics and international statistics. Obviously, a bit around why these are happening and why are we having issues with DC isolators, a quick top tips, and then we got some questions. Next, please. Next slide, please. So a little bit about myself. I've worked in the industry, mechanical electrical industry, for around over 10 years, specifically 2.5 years within renewable fire safety. A main driver is this: I identified a lack of standards and guidance around the UK, within the UK specifically, and I was looking at other markets, more mature markets such as Australia and the US, who have really stringent standards, and thought, well, we're missing a trick here. Why are we not learning from their lessons? Within the sector, I hold various professional memberships, and I'm continuously learning and maintaining my competence through CPD, such as even attending this today. So next slide, please, Matt. So some UK statistics. This was in 2018, so I appreciate this is dated now, but the British Research Establishment, the BRE, had identified that of a total of 80 incidents, that 47% of fires occurred specifically around from DC isolators. However, obviously, with an overall 75% related to DC issues around the PV solar installation. To date, this is the most current research available within the UK. However, myself and other members are currently in the infancy of conducting further research around solar PV fires. And obviously, when this does become available, we will publish it and get it out into the wider area, so people can learn from these and we can sort of, prevent these from happening. Next slide, please, Matt. So some international statistics. I've looked at the Australian standard, and Australia, who are extremely advanced in the uptake with PV, with more than 1 in 3 homes across Australia having solar PV. So in 2012, they introduced a mandatory rooftop DC isolator. And this was to protect first responders when attending during a fire incident, that the first responder can get up on the roof and isolate the strings at roof level. But that kind of backfired, because with that, they ended up seeing a 500% increase in solar PV fires related mainly around DC isolators at the roof level. And over that period in 2021, they ended up actually revoking this standard and putting other sort of measures in place, because they had that much of an increase that it was actually deemed ineffective, and it was actually causing more issue than good. Obviously, you've got some images there of the DC isolators installed, and within this time as well, over the period from 2012 to 2021, 30 product recalls were made for DC isolators. But let's be honest, as installers, etc., are you aware of product recall? Are you going to go back and rectify these out of your own cost? Unlikely. So them recalls around DC isolators were also more than likely a major impact of why these fires were occurring as well. Next slide, please. So the main common reasons why DC isolators fail, and this is internationally, this isn't specifically to the UK, this is what I've personally seen and witnessed from across the water, is that there's a range of factors, and I'll just briefly run through these range of factors of why this is happening. There's been incorrect selection in using AC, alternating current isolators, as opposed to DC isolators, possibly down to lack of knowledge. Incorrect selection of isolator based upon system string voltage and current. Again, as designers of PV, we need to be aware of what our design system voltage is going to be in current. And as Matt and Isaac went through earlier, you need to meet the requirements of the IMO isolator to that current. And that goes for all DC isolator manufacturers too. If you've got too much current, or you've got obviously too much voltage, that for that rated isolator, it's going to overheat. It's going to cause a problem. Often an issue around poor cable termination and torque setting, again related to manufacturer's instructions, referring to that, making sure it's done correctly. Obviously, with PV cable, it's fine copper conductor or tin even conductor. So best practice is using ferrules to terminate that correctly. Water ingress and shorting, put in stuffing glands, top entry, silly things, including conduit. This is all considerations of why water ingress may occur. There are some poor quality products on the market, and obviously lack of competence and training. And this is one of the reasons we're doing this here today, is to raise the standards and make you guys aware from an install perspective, is that DC isolators are a fundamental part of a solar PV system. And the correct selection and erection and installation of this needs to be done in accordance with the current guidance out there. I have personally had a failed DC isolator within my property, where the cheaply made non-knife switch isolator actually welded itself shut in the on position as it was meant to be switched. And obviously, as we are aware, we know that because they're modified AC, the switching mechanism, the arc causes, and the arc actually welded it into the on position in the contact, so it was unswitchable at that point. So this is the beauty about knife switching, is that it doesn't allow that to happen, or if it does, it's a very, very small, short period of time, which doesn't affect the isolator itself. Next slide, please. So just a brief top tips, really, how to mitigate these sort of PV fires, is that you should only obviously use DC rated isolators, and take in consideration in your selection the maximum voltage and current. Use DC isolators that minimize the arcing through the snap knife action. Follow manufacturer's instructions for cable termination and torque setting. And obviously, as an installer, we all are meant to be competent and suitably trained, and I think we need to be aware of the product and making sure we are competent to undertake the work we are doing. If we're not, obviously, then we shouldn't really be doing that work. And ultimately, to summarize and finalize it, we need to be selecting and erecting quality products that are fit for purpose and also for the proposed environment they're meant to be in. So, that basically summarizes it as a whole, is that, as installers, we need to be aware of this and, make sure that the correct selections are done and they're installed in accordance to manufacturer's instructions too. Next slide, please, Matt. And ultimately, I'd sort of end on this, is that life safety should always be prioritized over profits. And you know, as installers, we should always be selecting and erecting the correct products for a project, because cheaper isn't always better. You may save yourself 10, 15 pounds, maybe buying poor quality products. And obviously, you know, we all have a duty of care to do best by our customer for safety, but don't let profit, obviously, and greed overtake the ultimate life safety. That is pinnacle and key here. Next slide, please. Thank you.
Yeah, cheers, Luke. Thank you very much. I've actually taken your slide of questions out, and what we'll do is we'll pass over to Steve Humphreys from NAPIT now, and then we'll take all the questions in one hit at the end.
Perfect. Thanks, Matt.
No worries. Cheers, mate.
Yeah, good morning, everybody. My name's Steve Humphreys. I'm the Technical Commercial Manager here at NAPIT, and thanks for that, Luke. Really interesting thing there, especially on the stats. And some of the scary pictures, what we can see that actually goes wrong. And one of the things we do at NAPIT is we promote safety in all electrical installations, and obviously the surge in renewables is part of that, and solar PV. And our inspectors go out and have to be called out to incidents and see similar things to what Luke highlighted there with burnt out isolators and such like. And yeah, so it's not good. We need to make sure by doing things like this that we are not in a race to the bottom, that we are putting in safe installs and DC isolators included in that. So brief introduction to what NAPIT is. So we're a competent person scheme provider, and a lot more to say the least, where we provide training as well on solar and battery storage. And we work with organisations like IMO and other manufacturers, and sort of we want to promote best practice and safety in the industry. So we sit on various committees as well, doing that as part of the wiring regs and the JPEL committees and other committees around electrical safety first. And we work well with other partners in the industry to get this out there to our members and wider industry to make sure that what we're telling people is correct. So today, I'm going to give you a brief overview of what the regulations say. I'm glad it's early in the morning, because when I start talking about regulations, people tend to doze off. So I'll try and keep it as interesting as it can. But it's important that whenever we're installing any kind of electrical installation, be that PV or whatever, we need to make sure that we are abiding by BS 7671. So I don't know the kind of people that are on the call, so apologies if I'm teaching you to suck eggs here, but the wiring regulations are basically what we'd call the electrician's Bible. So all electricians and installers and designers would sort of work to BS 7671. So that's basically what it is. Big brown book at the moment. So the various regulations we need to look at when we're concerned with DC isolators, we'll find the first one is in regulation 712. So 712 is a part of the regulations that is classed as a special installation or location. Now, 712 specifically deals with solar installations, and we've got a regulation there that's very long, as you can see. But basically what that's saying is, you can see from the diagram, is that a switch disconnector suitable for isolation shall be provided on the DC side of the PV inverter. Now, I'm just going to pause there a minute, because in the regulations, what's handy is when you see something like the word shall, you can almost take that out and put the word must. Okay, so it's not a nice to have, it's telling you that needs to happen. So it's very clear in that regulation that we must have a DC isolator on the DC side. So like Luke and Isaac and Matt have talked about, we have seen instances where there's been AC on that side, all kinds of variants, or nothing at all. Okay, so it's got to be on that side. So you can see there, we've got it clearly labelled. Now, what's interesting in our industry recently is there's been a lot of talk around whether DC isolators are needed when they're integral to the inverter. So sometimes you'll notice on an inverter, they'll have a switch disconnector or some kind of switch on the bottom or the side of the inverter. Now, there was a document released last year in 2023, RC62, which talked about eliminating the need for DC isolators where possible. Now, like Luke talked about in Australia with those ones you saw on the roof, Australia very quickly realised that putting DC isolators absolutely everywhere was causing more problems than it was actually meant to do. It was meant to be for safety. And the RCC 62 document was, the good intentions of it were to say, well, if it's not needed, don't fit one because it's another point of contact that may fail. Now, NAPIT's stance and a lot of industry stance and people I speak to in the industry don't necessarily agree with that stance, because you've got to be really careful about what kind of isolation is fitted on that inverter. So is it a switch disconnector that's fit for purpose? So we released a technical bulletin this year that stated, even if there is an internal integral isolator, we recommend that a DC isolator externally is still fitted, obviously the correct one. So that's our stance, because we believe that things like saving money and saving time are not great design considerations when you're trying to promote safety. So as an organisation, we met with our technical team and decided that that was our stance. Went against a little bit of what was out there on social media, but we are where we are. We can all agree to disagree sometimes. So moving on to regulation 537.1.1, it also says there very clearly, any device for isolation and switching shall comply with the relevant requirements included in this section and included in table 537.4. So there's two regulations there that have both got shall in them that tell us we need to fit these things. Next slide, please, Matt. So moving on then to that actual table that I've just quoted, 537.4, this is where we get some guidance on what kind of isolation we should actually be fitting. So if you see where the red bit there, we are basically into a BSEN 60947-3, sorry for all the codes, and it's got a yes there saying that that can be used for isolation. But you notice there's a 1 and a 3 in brackets there. Now, this is really important when we're talking about using proper isolators like the IMO ones in this instance, because number 1 says function provided if the device is suitable and marked with a symbol for isolation, and it shows you there the symbol for isolation must be clearly marked on that device. And number 3 is also equally important. The device is suitable for on-load isolation. And what that basically means, like it says there, is it's able to disconnect while it's carrying load current. Now, if you think about a solar array that's generating during daylight, that is always carrying load current. So the isolator must be able to break that, not only make that. So not all isolators are the same. I like the phrase Matt used earlier, not, you know, apples for apples. Sometimes you've got to do your research and make sure that you are selecting the right kind of isolator. And also what you've got there is, you look under on note 1, an entry of 1 and 3 means that the device is suitable for on-load isolation only if it is marked with the symbol for on-load isolation. So you can see there that it's a bit of a difference in the top one, where it's got that almost like that little circle, so it means it's able to disconnect on load. So these are all really important things when designers, installers are actually selecting the right kind of isolation. Next slide, please, Matt. So just to, again, I'm not teaching, trying to go back to basics here, but what is a BSEN 60947-3? These codes can be confusing even to me, and I've done this for years, but you can see there that basically I've shown some diagrams of what they actually are. You've got the lovely shiny IMO isolator on the left-hand side there, also the integral parts of that isolator. And then what I really like about this feature is that safe lock. So is it lockable? It was interesting that when we went to Solar and Storage Live this year, I managed to get a little bit of a walk round and saw so many integral isolators on inverters that weren't lockable. So if you're going to work on that inverter, how are you actually going to isolate that safely and stop someone coming behind you? You could be working somewhere else and turning that back on because they see it in the off position. So a lockable device is absolutely key in this as well. So this does really meet all the criteria. So, you know, these things are commonly known. We said switching devices because that's the regs speak. But you know, we know them more as isolators or disconnectors. So like I say, really important that you select the right things and that they have got the right information on them. You can see there on the right, you know, you can see some of the approvals there and the kite marks, for instance, the CE marks that tell you that that product has got that safety aspect to it, and it's been built properly. Next slide, please. Now, if we wrap all this together, what we can see there is that these markings on the side are really key. So when I showed you that table, what we've got here is in black and white. So apologies that you can't quite see the images there, but what I've done, I've blown those up with the arrows on the right hand side. So I can clearly see there that this particular isolator is marked with a symbol as a switch disconnector that provides on load isolation. So it meets the requirements of the regs for that respect. And also you can see there that it's identified as an IEC 60947-3. Now the IEC, I had a BSEN number. We're just talking about the international number, but the more or less the same thing from that particular table. So like I say, I can't stress this enough. When you are selecting any kind of isolator, you've got to look at these things because they're not all the same. There are some really cheap imports you can get out there. You can go a little bit cheaper and think, oh, I'll save money on this install, but actually this is safety critical bits of kit that need to go in. And just going back to that technical bulletin we released on integral isolators, external isolators not being fitted. What we're going to say with that one is you can get integral isolators that do meet the requirements. And I know for a fact, because I spoke to Matt at the show, that IMO are working with inverter manufacturers to make sure the guts of these are fitted into their inverters. Now, in that instance, that's okay. Obviously, it depends on the install and where there are other isolation points, for instance. But actually, if you can honestly say that isolator integral, then you may then be able to eliminate the need for an external one. That doesn't change our stance. We're telling our members still to fit in, but that is designer's prerogative. But it's good to see that IMO are working with inverter manufacturers and having that conversation, because what I've seen so far is a lot of manufacturers aren't having that conversation. We need to have some joined up thinking. Coming to a close on this one, but what I would say just at the end of this is, as Luke mentioned, that there's lots of good work going on in the industry, especially with Luke and others and working groups. And I know my colleagues at Electrical Safety First are doing some research on solar fires, because we want to get to the bottom of this. We've seen the problems in other countries like Australia, New Zealand, parts of Spain and Portugal. We don't want that as these installs go in. We don't want that in the UK. So we need to establish what's causing these problems and sort of be proactive rather than reactive. And designers and installers do need to do that. And I can't stress enough on this as well. Like Luke mentioned, let's make sure the competence is there and actually you've got proper training. And a bit of a plug, probably a blatant plug for NAPIT, is that, we do offer that training on solar, on battery storage in this renewables world. You must get regulated training that's been approved. That's really important, and this will teach you these things about DC isolation and what ones to use. And also, do your research. There's really good publications out there. I'm going to plug our one again, which is a PV guide, which covers this stuff as well, on how to put these things in. So make sure you are doing your research on this kind of stuff as well. So I think that brings us, Matt, more or less up to time on taking questions, which I'm sure we're all happy to do. Thanks for listening.
Yeah, thank you very much, Steve, and thanks, Luke, both for your input. I think this is the point now where we're kind of wrapping up, but we'd like to invite any questions that the audience may have. And how do I do that?
I'm in the Q&A at the moment, but I can ask the questions if anyone wants.
Is there any questions from anybody? I'm just going to allow all of your microphones as well, if that was the problem. Right, there's quite a few people, guys. I've just allowed your microphones, so hopefully that might have stopped any issues that you might have asking any questions.
Will this presentation be available so I can give it out to other people within my organisation?
Yeah, of course it will. What we can do, it's quite, as you can imagine, it's quite a big file to send by email. So what we will do is, if you send me an email, then I'll use a WeTransfer, and then you can download it yourself from the internet.
Thanks, Matt. Could I have your email address again? I wasn't quick
Yeah, of
enough to
course.
write it down initially.
Yeah, no problem. It's m.siddon, as my surname is spelt there, and it's at IMO and then PC for precisioncontrols.com. So m.siddon at imopc.com.
Thank you ever so much.
Thank you. Were there any other questions? You can write them in the Q&A as well if necessary. No, okay. Well, we must have done that good a job explaining the differences between modified AC and regulations and safety. So if that is all, I'd like to thank you everybody for your attendance. Please do. Oh, sorry. There you go. Where can we get the combiner boxes from Charlie? You can get them from your local wholesalers if you request them, or if you, even better still, if you got the details of my email address, if you send it to me, then I will point you in the right direction as to where you can find them. Yeah, thanks for your question, Charlie. They're still coming through. I'll just give it a minute just in case anybody else has a question on the combiner boxes, if it's anything regulatory, safety. Right, okay, we got another one. Right, okay, what's the difference between on 16 amp DC isolator for a single and 2 string? Isaac, do you want to answer that one?
So you can use with the IMO range, you can use the same 16 amp isolator, but effectively if you need multiple strings, instead of going 2-pole, you might need to go to the 4-pole option for 2 strings. So effectively, you're going to get the same load capacity across each pair of poles. So we would say if you wanted, you had a 2-string system and you wanted to switch it with a single isolator, go with an SI16, which is IMO's 16 amp DC switch, but go for the 4-pole option.
Yeah. So just to summarize that, the product code, if you wanted the enclosed box, it would be an SI16 and then it's a PEL64R. The -2 on the end would indicate that it's a single pole, so a 1 string, and the -4 is a 2-pole. The difference in the ratings, you got as standard, you can put, if you went for the 2-pole version, so the -4, 16 amps at 900 volts per string. So you get 900 volts around both strings. Hope that answers your question, Winnie. We'll just give it a minute for any more questions to come through. Is there a problem with the microphones? Can everybody jump in and actually ask the questions that they need to now?
I think they're all just shy, Matt. They're just gone shy.
Yeah, fair enough. Okay. All right. Well, in that case, we'll wrap it up then. But thank you everybody for your inputs, your questions, and